that the sequence n squared over n factorial from n equals 5 to infinity converges to 0 is the same statement as saying the limit as n goes to infinity of n squared over n factorial is equal to 0. There's two ways, notational ways to write the exact same statement. Yep. Other questions for him?
How do you calculate the factorial part?
Oh, okay. Like on the math website, like he gave them to us. It's like 0 to the factorial equals 1, 1 to the factorial equals 1, 2 to the factorial equals 2 times 1, 3 to the factorial equals 3 times 2 times 1.
Oh, okay, I got it.
Like you just
Yeah, I got it.
All right, other questions? All right, so now, on the test, you've got to be able to prepared to show, right? You've got to be prepared to do exactly what he did there. Can just convince me that it decreases and tell me what it converges to. Looking at the limit is a perfectly good way to guess what it converges to. What do you have to do to prove that this thing decreases? What do you have to write down and solve?
N squared over n factorial is greater than n plus 1 squared. N plus 1 factorial.
Right. Is that you didn't have to do that, did you? No, it's not. Some of these are just later problems. That's what I have to show, right? Pardon?
Flip the sign. Flip the sign.
It's decreasing.
It's decreasing, so the next one should be smaller. Thank you very much. Right, this one should be smaller than this. It is decreasing. I'd have probably figured that out later on when I got 1 was less than 0 or something, right? If I'd worked my way down. So let's just do it. N plus 1 squared times n factorial, multiplying across, n squared, n plus 1 factorial. Well, n plus 1 squared, this is, as he just said, that's n times n minus 1 times n minus 2, all the way down to 3 times 2 times 1, right? That's what that n factorial is. So it's less than n squared times, what's n plus 1 factorial? What's n plus 1 times n minus 1 times n minus 2, all the way down to 3 times 2 times 1. Are you clear on what I just did? I just wrote down the definition. Yeah, Dominic? Right?
So the least upper bound would be 0, and the greatest would be 25 over 120.
Let's see. Yeah, that's the largest it ever is. So you're correct. That's a good question. That's the least upper bound right there. And the greatest lower bound is 0.
Why is it the least upper bound? Like, I don't know why I'm not grasping that.
Draw the picture on a number line. He put 0.208. The next one was 0.050. The next one was 0.0047. They never get to 0.
Is it because we started n equals 5?
Right, this is A. We would label this A sub 5. We would label this A sub 6, which he didn't, but I think he knew it. Right, A sub 5 is this one, A sub 6 is this one.
So if we started at 6, it would be the 0.050?
Right, exactly.
Are we supposed to prove those bounds?
On the test, you have to be prepared for a question that just says, tell me everything you know about this sequence. Then you might say, this one's non-increasing, and you might say it converges to something, and you might tell me the least upper bound and the greatest lower bound. You might just list everything you know and list a few terms of it. Or, I might say, prove that this sequence decreases. Or I might say, find the greatest lower bound and the least upper bound and prove that they are. So I might ask you to prove something. I may just ask you to tell me information about it. You've got to be prepared for both.
By proving it, we did that right there.
Yeah, that's what I'm going through. Depending on what proof it is, right? But if I'm saying prove that it decreases, what do you have? Definition of decreasing. the definition is that a sub n plus 1 is less than a sub n for all, in this case, it would be n equals 5, 6, 7, right? Because we only started at 5.
What about moving it down? Like, how would we do
Well,
it?
that's a different problem.
Okay.
One at a time. Okay, so I'm trying to figure out if this decreased. Everybody see, I just wrote out what n factorial was. I wrote out what n plus 1 factorial is. But look, there's a 1 on both sides, right? There's a 2 on both sides, all the way up to everything cancels. Or a whole lot of it cancels. And I'm left with n plus 1 squared less than n squared times n plus 1. Well, it's not obvious to me if that's true or not. N squared plus 2n plus 1 less than n cubed plus n squared. Cancel again. This one I wouldn't give you on a test, but I'll, because you're going to have trouble showing it. Right, move these guys to the other side. Flip it. N cubed minus 2n minus 1 greater than 0. Well, if n is 0, that's not true, right? If n is 1, that's not true. 1 minus 2 minus 1 is not greater than 0. If n is 2, 8 minus 4, okay, it starts being true at 2, right? It's certainly true from 5 on, but how do I prove it? Well, I can't really easily, well, what I'd have to write now is something a little bit complicated. Well, n...
Doesn't n start at 5?
It does. It does. But I was hoping to get it down to something like 1 greater than 0. You see what I'm saying? Something that you can never, nobody can argue with. I'm trying to get it down to something that everybody is obvious. How do we know this is always greater than 0, right? I mean, I could graph it on a calculator, but then I have to believe my calculator. So this might not be the easiest thing to show. So this one's not a good example, because the ones I'll give you, you'll be able to reduce them down to something that you absolutely know is true, and then reverse them. I'm trying to think how I could really show that. That's equal to n squared times n minus 2, all minus 1. Okay, if I factor it out like that, then I can say n's bigger than 5, right? So that's positive. And this is positive, right? Since n's bigger than 5. So that's positive and that's positive. So when I multiply them, they're positive. So if I subtract 1 from something that's positive, it's got to be at least bigger than or equal to 0. So I can get, since this is bigger than 3, right? This is bigger than 0, so when you multiply them, they're both bigger than 0. So you can get it, but that's kind of a nasty one. I'll make it so it works out to be something. If I give you one to prove, it should work down to something simple. I just wanted to talk about what you have to show. Now, somebody asked about the upper bounds. So what do you have to be able to show for the upper bounds? You have to be able to show, so prove 25 over 120 is an upper bound for n squared over n factorial. Well, you have to show that n squared over n factorial is always less than or equal to 25 over 120. So you need to multiply. That's what you have to show. So I need to show that n squared 120 times n squared is less than or equal to 25 times n factorial. So I can show 120 times n less than or equal to 25 times n minus 1 factorial. Right? Little clever trick. I'm pulling an n out of here. This is n times n minus 1 times n minus 2 times dot dot dot. So that's just n times n minus 1 factorial. 5 factorial is 5 times 4 factorial. Why? Because this is 5 times 4 times 3 times 2 times 1. And this is 5 times, 4 times 3 times 2 times 1. Right? You can always take the top one out. Okay, so now I can divide through by an n on both sides. I can divide through by 25. 120 over, let's see. That's not going to help me, is it? Let's leave that 25 there. So I've got 120n less than or equal to. Okay, so I chose a really bad example to show you how to do these because neither one of them is easy. Okay, I don't like this one anymore. That's why I didn't ask you for this one. The ones that I'll ask you to prove, factorials are often kind of nasty when you're trying to work with them because the algebra is not simple. Yeah.
I'm not really understanding why you can take out that n minus 1 for the factorial.
Because n factorial is n times n minus 1 times n minus 2 all the way down to 3 times 2 times 1, right? What's n minus 1 factorial? It's n minus 1 times n minus 2 all the way down to 3 times 2 times 1, right? So if I multiply this one by n, don't I have that one?
Yes. I understand.
Let's see if I can do anything with that nastiness. I don't like it.
Yeah. Throw in the towel.
Yeah, I think unless we want to spend another 30 minutes with me trying to pound through some ugly computations, I think we got to throw in the towel. Sad face for Ted today. Made up, chose to try to work a problem he couldn't work in 30 seconds or less. Okay, show us what you got.
Well, this says consider the sequence, which is this, without the minus. It's just this problem right here. Then it says this, well, I guess it's e equals 0.0002, and then it says find the smallest natural number n, so that this problem right here is greater. Means less than this. Then it says for every n that is greater or equal to the big N. So if it's inside the absolute value, so I separated it. I put, usually this is the same number, but I just separated it. I put 5 divided by 3, behind is 0.00002, less than the problem, this problem right here. Well, actually, I'm sorry. It was this right here, negative, with this on the inside. I just distributed this to the outside of both sides. That's why I have this right here. So I did that, put that in there, I did it over here too. This one always true because n, which is this right here, a is an n, is decreasing, this decreasing. And this one you have to solve for to see if it's true. So I distributed this, I multiplied this from the top and then over here. And then I distributed this number to the problem, got this, and I did this algebra and got this less than the n.
That's a pretty big natural number he's got to get. Let me spend some time on this one, and because I think this is the day we're going to either figure it out or not figure it out for this. Can I erase this one? Okay. So let me see if I can help with that one. That's Johnny's got it. He's done what he's got to do. Let me see if I can. I only get a few minutes on this convergence last time. I want to see if we get it. I'm going to erase this evil problem. Even sitting back at my desk, I don't see how to do it for 30 seconds or less. Okay. So let's start with, right, the sequence we're talking about is 5n plus 4 over 3n, is it plus 1? Plus 1. N equals 1 to infinity.
Minus 5/3.
Yes.
Yeah, no. The sequence, this is, yeah. Thank you. Okay, this is the question. I want to know, what does this converge to?
Oh.
Okay, let's go back to the limit question first. So intuition. And what does this converge to?
5/3.
Right, 5/3. You can see that a couple ways. You can say, well, 4 and the 1 don't matter much. You put a billion in, you get 5 billion in 4 over 3 billion in 1, which is basically 5 over 3, right? Or you can do some fancy algebra to it and write multiply the top and the bottom by 1 over n. That'd be 5 plus 4 over n over 3 plus 1 over n. Well, what's that going to? 0. What's that going to? 0. What's the whole thing going to? Now, what's another way to? What's a way to kill this mouse with an elephant gun? L'Hopital's rule from last semester, right? The top's going to infinity, the bottom's going to infinity. Therefore, this is the same as which is the limit of 5 over 3, which is 5/3 again, right? Okay, so we know all kinds of ways. You can just do intuition. It's bound to be going to 5/3. You can do college algebra with a little bit of calculus in front of it. Or you can do calculus 1, L'Hopital's rule. Anyway, we know what it converges to. Okay, the definition of convergence says the definition of convergence says the sequence A sub n converges to L means if epsilon is a positive number, then there is a positive integer n so that A sub n minus L is less than epsilon for all n greater than or equal to n. Now that's just a mouthful, okay? Like I said, mathematicians spend 100 years or more trying to figure out that statement. So if it takes a little while for you to figure it out, that's okay. Let me write it geometrically. Here's L. Suppose we have a sequence A1, A2, A3, so that it's going towards L. What are we saying here? What we're saying here is, you give me any tiny positive number. I'm going to take L plus that positive number over here. I'm going to take L minus that positive number over here. And I'm going to rewrite this nastiness without the absolute value. Now, if the absolute value of x is less than 3, where is x on the number line? Between what two numbers? 3 and negative 3, right? So this means negative 3 less than x less than 3. So this means negative epsilon less than A sub n minus L less than positive epsilon, right? So this says that A sub n minus L, let me rephrase that. This says in English, A sub n is no farther from L than epsilon.
So is L going to be the lowest upper bound?
If it's increasing, it would be the least upper bound.
Okay.
If it was
Whatever
decreasing,
it's going to.
whatever it's going to, it's the point of convergence. It's what it converges to. In our case, I'm going to do the specific example here like he did in a few seconds. It's 5/3. But I want to give the big picture first. But yes, you've got it. So if I add L to both sides, I have L minus epsilon less than A sub n less than epsilon, L plus epsilon, right? That's what I drew in my picture, wasn't it? I'm saying if this sequence converges to L, then no matter how small an open interval you pick around L, there's got to be a time, or a number, capital N, where the sequence gets inside that interval, and it stays in that interval forevermore. If you go home to your apartment today, and you make it there, then no matter how small a circle I draw around your apartment, at some point you got to get inside that circle, right? Otherwise you're not going to make it to your apartment. If I draw a circle around your apartment and you never get inside that circle, you're not getting home. That's all this says. How big is the circle? As small as I want it to be. I could draw a giant circle around your apartment. It would include all of us right now. Right? But if I drew a tiny circle around your apartment, just a teensy-weensy one, just barely outside, you still have to cross it to get inside. So that's what this says. This says that if I pick a tiny distance away from L, no matter how small, there will be a natural number n, at which point that sequence gets inside there, and one more thing, it stays in there forevermore. So unlike the apartment analogy, for convergence you have to get into the apartment, you have to stay there forever. Okay, let's look at what he had to do over here. He had to show this sequence converge to this number. So that's my L, and these are my A sub n's. Let's look at them on a number line. What's A1 equal to? What's A1? 9/4. What's A2? 14/7. Is that bigger or smaller? Okay, I'm trusting you. If we end up, oops, that was a 1. 1, 2. What's A3? 19/10. Yeah, this one's 2 1/4, isn't it? So this one's definitely smaller than that one at least. Okay, so somewhere over here is 5/3, right? So I picked an epsilon and I gave you a number for epsilon. So I'm talking here 5/3 plus 0.0002. How many zeros are up there?
4. The 5/3 you got from the limit.
Correct. This is what it's converging to, right?
But what about the minus 5/3? Wouldn't that make it 0?
If we ever got there. But this isn't quite like your apartment. It's more like I'm walking towards the door, but I take smaller and smaller and smaller steps, right? I never get to the door. Because this one's bigger than this. Every one of these numbers, 5n plus 4 over 3n plus 1 is always bigger than 5/3. 5/3 is the, what, greatest lower bound for this problem. That is the greatest lower bound. They're always bigger.
Oh, it's approaching it, but it never gets to it.
Correct. It approaches but never gets to it. You got it. Okay, so now, here's 5/3 plus my tiny neighborhood, and here's 5/3 minus my tiny neighborhood. So the goal is, what's the number n? For this tolerance, how many steps do I have to take to get inside this interval? Well, when we translate this is what he did, but he did it in 2 steps. He wrote it out. This is right, just like I did over here, getting rid of, I don't like absolute values, right? None of us like absolute values. So we make them go away. Then I add the 5/3 to both sides. 5/3 minus epsilon less than 5n plus 4 over 3n plus 1 less than 5/3 plus epsilon. All right, insert that right there. Now, look at the two halves separately. This is the left half, right? Star 1, star, star. That's the left half. Now, what did he say here? He said that's always true because it's decreasing, right? It's going this way towards 5/3. So don't you agree that every term here is bigger than that side of the interval? It's even bigger than 5/3, right? So every one of these, every one of our a sub n's is bigger than 5/3, so it's also bigger than 5/3 minus that positive number. So he didn't worry about this side. That's the way it's not the way it's always going to be. They can bounce back and forth, but I'm not that evil. That's the way it's always going to be. If I ask you to prove convergence, you'll only have to worry about 1/2. It's hard enough to ask you to prove theorems in calculus. That's a mathematical thing, not an engineering thing. So it's evil enough of me to ask you to prove theorems. So if I ask you to prove one, I promise you, like this, you can one side of it you'll be able to ignore. Now look at the other side. I have to find out what value. Really, this should say I want to find a natural number n so that this is true. That's what it ought to say. Not that he had to write that, I'm just saying that's what he's saying. He's saying, how do I find the natural number n so that I get less than this number? What does that mean? That means I crossed this line, right? I made it into my neighborhood. Now it's just algebra. So he figured out what this is. He multiplied across by 3n plus 1. So 3 times this is that, times n plus this times 1. Now what do? You subtract 5.006 from this side. You subtract this from the other side. 4 minus that is that. You divide through by 0.006 and you see this. So capital N. So if capital N is 38,889, then a sub n is less than 5/3 plus for all n equal 1, 2, 3, ... right? That's what he found. He found the magic number, capital N, that works for this 0.00002.
So what would that number do?
Pardon?
Where would you put 38,000? Like a sub 38,000?
Right. So what I can say now is that a sub 38,889 is less than 5/3 plus 0.00002, but also, right? Remember, in this case, they're decreasing, right? So once you get inside there, you're always in there. There's really two more things to prove here. There's really two more things to do. I'm about out of time. I know we're not going to get those problems back, but I think it was important to do one of these very, very thoroughly. There's two more things to show. What are they? My picture shows what? Shows two things geometrically that I didn't prove. It's decreasing. 1, a sub n plus 1 is always less than a sub n, i.e. 5 times n plus 1 plus 4 over 3 times n plus 1 plus 1 is always less than 5n plus 4 over 3n plus 1. Because you need that, right, Johnny, in order to claim, well, you don't need it for that part, but in order to claim that this one we know is inside, but how do we know all the ones with a larger subscript are inside? Well, only if they're decreasing, right? So that's one thing we need to do. Lots of work. What's the other thing we need to do?
Word convergence.
No, this is, well, if we had done this with arbitrary choice of epsilon. If we hadn't filled in what E was, what epsilon was, and it just left an epsilon here and an epsilon here, we would have proved convergence.
Are there any bounds on it?
That's the last thing we need to show. We need to show that the really that's always bigger than 5/3, right? Because what if it went past 5/3 over here and kept going? Then it wouldn't always be in the neighborhood, would it? It's got to get in the neighborhood and stay in the neighborhood forevermore.
But it never passes 5/3, correct?
Right, it doesn't, but we didn't show that. I'm just claiming that, right? What if it bounced around, came over here and went back and forth or something? I can generate sequences that do that, but I won't do that to you.
So is 5/3, I'm sorry.
Go ahead.
Oh, is 5/3 the greatest lower bound?
5/3 is the greatest lower bound, but we haven't proved it.
Oh, you just proved it back.
That's what I'm saying. There's two things left to finish this proof. One is to show that it really is always decreasing. Two is to show that it really is always bigger than that. Because if it's decreasing, and you got it inside, and it's always bigger than this, then every number A sub n is in there as long as n is bigger than or equal to that number. Questions? Other questions?
What are you solving for on 1 and 2? Like, how would you do like 1?
I would just do a whole ton of algebra. The first step would be 5n plus 9 over 3n plus 4, less than this, right? I'd cross multiply, I'd cancel all kinds of things, I'd end up with 0 greater than -2, or some true statement. And then I'd reverse it.
Is 5/3 plus E or epsilon, is that the upper bound?
The upper bound for this one, the least upper bound for this one is that first term, A1, which was the biggest term there was in the whole sequence. Because remember, it was decreasing. Once you prove it's decreasing, you know this one's the biggest one.
It started at n equals 1.
Right. Started at n equals 1. All right, stay off the streets.